Hi guys, my name is Paul Murphy, and today I'm going to discuss running your LLM fine-tuning operations on a centrally controlled system. Today I'm going to run through fine-tuning an LLM, the problems that we see when we're running it, and how the centrally controlled system will help. So you're probably wondering what a centrally controlled system is, and I will get into that shortly. But before I get into that, I first want to discuss the current state of LLM training in 2023. So we can't discuss LLM training in 2023 without first discussing Hugging Face. Hugging Face has been a game changer in the industry. It massively simplifies serving your models. It makes versioning your models and your data sets so easy because it's state of the art. And also, using its SDK, it's become much simpler to train or fine-tune models. So that's what we're going to do today. We're going to use the Hugging Face SDK to create a model, and we're going to see what problems we see, and then we're going to see how the centrally controlled system can help address those. So today we're going to build a sentiment analyzer for reviews. And so what a sentiment analyzer for reviews does is it looks at a text review and it figures out what numeric score that the writer of that review would have given the product. So for example, if the review was "this food is awful," presumably that would have been a 1-star review. Whereas if someone wrote "location is fab" and staff were amazing, it's a 5-star review. Now it's easy to see why this is useful because it's often good to be able to take text reviews of products and give them more numerical values that we can analyze later. Okay, so we're going to use the Hugging Face SDK. What the hell? So the first thing you need to do if you're fine-tuning a model is you need to load your data set. And as I was saying, Hugging Face has over 70,000 data sets, and it makes it incredibly easy to load a data set. All we need to do is give the name of the data set we want. And in this case, there's already a perfect data set, which is called the Yelp data set. It is text reviews of the places and the products, and then the label is a number of stars from 1 to 5. So first of all, we load the data set. Next, we want to use a base LLM model. So in this case, we're using the BERT model, and we say, use the BERT from pre-trained, and we want to do sequence classification. So what sequence classification means is that we classify a sequence of text into a number of buckets, 1 to 5, 1 to 5 for 1 to 5 stars. Okay, so now we have our data set and we have our model. We want to start the training. All we need to do now is just pass in a few arguments. Like, first of all, we need to say, well, once the training is finished, where will we save the model? Where do we save the checkpointing files? And what reporting platforms do we report into? So here you can see that we're reporting into weights and biases. Then we just pass all that into our trainer and hit train. Now, that's basically the amount of code you would need to build a sentiment review analyzer. And so you're pretty happy, you've written your code, but now you're wondering, well, where do I run it? And so, the most simple approach for running it is, if you have a GPU on your own computer, run it on your own computer. And if you don't have a GPU on your own computer, well then, provision a GPU in the cloud, and then, clone the code onto that and run it there. And that is how, a lot of people get started. But, in a large organization, there are a large number of downsides to this. Obviously, once the model is created, there will be a lack of traceability into which version of the code created that model, which data set was used to create that model, even how much epochs was used to create that model for trying to reproduce later. Also, especially if you go with the provisioning the GPU, it's a very manual process and it's extremely ad hoc. If you work in an organization, you might not know what GPUs you're allowed to rent for an hour or two, which ones are outside your budget. So, as a machine learning engineer, you've written your code, you just want to be able to deploy it and run it in a single click and produce a model that people can consume. Also, there was a lot of responsibility placed on you as a developer. Like you were in charge of choosing the storage layers, which was S3 in the previous example, the reporting platforms, like weights and biases, and also it's in the code, or you would decide if we use GPUs or not. We don't want, as a machine learning engineer, we just want to focus on writing code. So this is where the centralized control system comes into play. I just want to caveat this by saying as well, some of the features here discussed are like a work in progress. And so not everything here is necessarily fully implemented as of yet. But so this is where the centralized control system comes into play. So the centralized control system we're going to discuss today is Versatile Data Kit. It's an open source project by VMware, and it's the project I work on in VMware as a software engineer. So what does Versatile Data Kit do? Well, it's made up of two components. There's the control plane, and there's the SDK. And we're going to first of all talk about the control plane. So what the control plane lets us do is anyone can write just a piece of Python code and submit it to the Versatile Data Kit control plane. The Versatile Data Kit control plane will take that Python code, and then based on the configuration parameters that the submitter submitted, we will create an appropriate Docker image and the appropriate Kubernetes YAML files, and then we will deploy it to Kubernetes on behalf of the machine learning engineer here. Then, obviously, Kubernetes is responsible for running the jobs. But all the while, Versatile Data Kit is monitoring the job. It will handle, reporting metrics into different systems about the health of the system. And also, if for any reason there's a failure or a success, the original deployer of the job can subscribe for notifications. So the benefits here are, firstly, separation of concern. As an ML engineer, my code gets running Kubernetes, which is what I want. But I don't have to focus on the Docker images or any of that stuff. I focus only on what I know. Secondly, there's no it works on my machine problems. A lot of the time, like if you're manually provisioning these GPUs, you might go into that GPU and set up a few environment variables, and you forget to document them, and then 6 months from now, it's really hard. If that for some reason is becoming your best model, it can become really hard to reproduce that because everything wasn't documented properly. But the fact that everything that is needed to run on VDK is submitted in one go, and it's essentially immutable. It's checked into Git. So if that's your best model and you want to rerun it, it becomes easy. There's no it works on my machine problem, and there's perfect auditability. We will always know moving forward, this model was created by this data set and created by this version of code using this number of epochs on this date. And so I think, like, if you were a machine learning engineer using this product, you'd be pretty happy at the moment in that, like, now I can just run stuff. If I want to run 10 training models with different hyperparameters, at least I can do it fast. But from an organization point of view, there's actually still a lot of downsides in this code. First of all, there's vendor lock-in here. Like the machine learning engineers hard-coded S3 here, and they've hard-coded the reporting platform as WMB. And it's not that big. And so also there's like a very subjective naming convention here. I named it First Analyzer because it's my first review sentiment analyzer. But like that won't really make sense to someone in 6 months from now. So we want much more, in an organization, you want a much more standardized approach here. It's good for both. It's good for the machine learning engineer and it's good for the organization, because as a machine learning engineer then, you don't need to find out these details. And also, there's another issue here. Obviously, you want stuff running on Kubernetes because it's kind of the status quo now. But like pods in most applications that we write, we aim to make them stateless, and so pods are very appropriate for that. However, in Hugging Face, when you do training, Hugging Face actually pulls down the data set on the first epoch. and then it stores it on that machine. And so if you have to rerun a job with different training hyperparameters, or if your job fails for any number of reasons, you can restart the job really fast, and all the data sets and all the models will be already on your machine. However, in Kubernetes, that wouldn't happen by default. So there's 3 main issues in this code. Now, this is where the VDK SDK comes into play. It allows the configuration of all jobs to be managed centrally. And it decouples your jobs from your model storage layers and your reporting platform, your ML metrics reporters, and also from whether you want to use GPUs or not. So we'll go back to this code again. So now the machine learning engineer doesn't have to think, where do I save my model? All they have to do is say job input, get training arguments. And the VDK cluster supervisor can say that, look, we want to save all models to S3. We want the naming convention for where models are saved to be, team name, organization, group, and then we want the date in the path, and then the commit message attached in the path. Or the commit ID, maybe, to make it easier for someone to trace. Also, we were reporting the metrics into weights and biases originally, but we see that there's actually a better platform on the market now. We want to start using that, but we don't want to rewrite all the code in all our jobs. The fact that there's a layer of separation between the code and the configuration means that we can move provider without needing to rewrite any of our jobs. And also, it's in these arguments that you configure, like if you will use GPUs, even if you will use multiple GPUs. I'm actually running out of time. So there's a few other benefits, like I didn't get into the caching, but obviously because there was separation of concerns, Kubernetes admin can configure persistent volumes for your pods in which you're running this. If this is something that interests you, we have a Twitter account, which is VDK Project. Our open source project is Versatile Data Kit at GitHub. We would love if you guys would follow us. And if this is something that is interesting to you, please reach out to me. You can reach out to me directly at paulm2@vmware.com. And we did 2 previous presentations already at VMware Explore that you could check out. Thank you.